Welcome. Today we are going to look at how to calculate moment of inertia, that is Ixx. So today we have this given structure, and here this is the solid part and these are voids, and we've got some given information. We've got a y bar, that is the send rate for this material, and A1 area for 1, and A2 area for void 2, and AS, that is the area for the solid part, right? And these are the parameters for this structure. So for us to get Ixx, that is the moment of inertia, we're going to use this formula, which says Ixx moment of inertia, and this is what we're looking for, is equal to Is minus I1 minus I2. So these are moments, individual moments of inertia. Those are estimated, and we can calculate them for this structure, right? So for Is, right, this is the Is, and this is Is. We just written them separately here. We've got this formula which says Ixx for the solid part, and we add it with this parameter now, which says area for the solid material and the difference in the send rate and distance from estimated from the base to the middle point of that part. Let's say, for example, we've got this material, the y difference in send rate in that part will be the distance from this base up to the midpoint for this part, and we are going to solve it as we move on, right? So for Is now, this is the formula, and for I1 this is the formula, and for I2 is just the same. So for Ixx, for each and every one of the Ix's which are going to calculate here, we've got this special formula which says 1 over 12 BD cubed, where B is the base for the material base we are going to calculate, and D, that's the height, and we're going to cube it as we calculate. So let's move on. So for Is here, we say it's equal to, for Ixx, we're going to use this one, for this is the individual Ixx, right? So which is equal to 1 over 12 multiplied by the base and the height cubed, right? And we're going to add it with As and difference squared in the send rate in the send rate and the distance from the base to the center of this material that we have, right? So as you can see now, we are just going to substitute and plunge in some digits that we have from the given information here. So let's move on. Is will be equal to 1 over 12. So what is the base for this material? For the base is 0.32, because with these are millimeters, so it's 0.532. And what is the height? We've got, this is 700 millimeters, so it's 0.7, right? So 0.7 cubed, and we're going to add the area for the solid material, which is 0.3724. okay, 0.3724. And now what is the difference in the send rate? We've got the send rate is 0.374, right? 0.374, and I'm going to subtract it with midpoint for this solid part, right? So for 700 millimeters, we're going to divide it by 2, so it will be 700 divided by 2, it will be just 350, so it will be 0.350. You're going to square this. Okay, so let's put these figures in the calculator and see what we're going to get here. So for 1 over 12, and you multiply it with 0.532 and 0.7 cubed, and we're going to add it with 0.3724, and we're multiplying it by 0.374, subtract 0.35, we're going to square, so get something like 0.0 0.0154. Okay, so this is I for the solid part. Okay, so we're moving on now to I for 1. Okay, here I for 1, so we say it's equals to 1 over 12, and with the base and the cubic for the height, and we're going to add the area for 1. So the area of got 80 from the given information is 0.04. Okay, so 0.04, and I'm going to multiply it with the difference from the center and the midpoint from the base to the midpoint of this square. So from the base now to this point, we see that from here to here is 200. 200 divided by 2 is 100. So this is the midpoint for this square. So 100 from here to here, and another one is 200, 400, 500. Okay, so it's 0.5, and subtract now the centroid, it's 0.374, and we're going to square this one, right? So we're going to use our calculator, and let's see what we get here. So for the base now, for the base of this square is just 0.2, and now also here it's 0.2, but it's just a square. So for us now, we say 1 over 12. Let me just write them down, and then we'll use a calculator just as once. So it's 0.2, and multiply it with another 0.2 cubed, and I'm going to add this one. So since now we have the digits, we're just using calculator it. So it's 0.04, we multiply it by 0.5 and subtract 0.374, and you square this one. So it's 0.00635. Okay, so we're going to add this 0.00635 with this one. So just add it here, and as we add it with the 1 over 12 of 0.2 and 0.2 cubed. This is what we get. We have from the calculator 0.00077. Okay, so this is what we get from the calculator. So now we're left with only I2. So for I2, we're going to use this formula, which is say I2 is equals to IXX2 and A2 and the difference squared. Okay, so we're going to use this formula for the IXX for this individual, that is going to use a 2 here. We're going to use the same procedure that we've been using it. So if you use that same procedure, you get this value for 0.00268. Okay, so now we're going to calculate for IXX. So our IS now, this is IS, that is 0.0154, and we're going to subtract our I1 is 0.00077, and we're going to subtract also for I2 is 0.00268. So now the final answer will be, let us use our calculator here, 0.00154. We subtract 0.00077, and we're also going to subtract 0.00268. So our answer will be 0.01195. Okay, so I'm going to write it here, 0.01196, and these are the units. okay for that. So thank you for watching, guys. Hope this video has been useful to you. Don't forget to subscribe to my channel and also to hit the notification bell, because I'm going to throw more videos in how to solve different problems in mechanics. Please, if you have any question, just highlight them in the comment box. And also, if you have any unsolved problem, we can try to solve them, and just notify us in the comment box. Till next time, bye bye.